Welcome back. Let's conclude our latitude and longitude section. I wanted to share this slide with you guys. This is illustrating the different time zones in the world. Okay. Note that your time zones are going to be separated by 15 degrees of longitude. Okay. And so with the Earth being a spherical, circle shape, note that there's 360 degrees in that. And if you cut 360 degrees by 15, what you end up with is 24. So think about it. Every time zone is split up into 15 degrees, which gave us 24 hours in a day. Okay, that's how this stuff works. And so longitude is actually another thing that's very helpful for determining time, because we've got that east-west position that we're effectively measuring for, and understanding. Therefore, you can determine where the sun is as it's rotating around. As the Earth is revolving around the Earth, and as the Earth is rotating its axis, where's the sun in relation to all of those things? That can become where you determine what your specific time zone is, based on longitude. Okay, so beyond this rant I'm talking here, let's look at this example and let me try to explain. So what we've got here is the planet, in what's known as a Mercator projection. Okay, so it's flattened out for us in this map. And you've got 0 degrees longitude here, each one of these various longitudes per se. But 0 degrees longitude here, okay, so there's your prime meridian. And notice that it runs right through London, okay? And we call this Greenwich Standard Time, okay? You might see that in reference as you're looking at timestamps for, say, a bank transaction or something else. You'll notice how many hours difference it is from Greenwich time, which is let's say, kind of the halfway point of a day, okay, in the middle of a day. And now on the opposite side of that, we have what we mentioned earlier, the IDL, or the International Dateline, 180 degrees right here, okay? So 180 degrees would be, let's call it the beginning and or end of a day, okay? The beginning and or end of a day. These are the two tools that we use to determine our various time, okay? In addition to this whole 15 degrees apart each one equals an hour, various times throughout the day. So this is just kind of an interesting thing. And notice that as we're looking through this, that it's not as scientific as we might think, okay? And the reason for that, so what I mean is, like, okay, so say for example, you've got these 2 lines of longitude here. Or actually, Greenland's a good example. So Greenland spans between 60 degrees west and 15 degrees west longitude, okay? That's a pretty significant amount of distance to go. But notice that overall, Greenland itself only has one, notice that's all one color. Greenland is only one time. It's all one time zone for the most part. I see some outliers here with a little bit of green, a little bit of orange. But for the most part, let's say note here that Greenland is all yellow. Now, that does not mean that 12 o'clock or let's just use 3 p.m. on the West Coast looks the same as 3 p.m. on the East Coast, because it doesn't. It totally would look completely different. One side would be darker than the other, okay? But because of time is essentially something that human beings can not control, but we can, manipulate to what makes sense, for us. Political geographers and political administration would say, okay, you know what, Greenland, we all just want to be on the same time zone. Forget it. Like, it doesn't matter to us. We're all gonna be in the same time zone. Okay, well, so that's what happens. Another example of that would be in China. If you look at China, right? Think about the United States and how big it is, right? It's 3,000 miles plus from one side, from the West Coast to the East Coast. And with that being said, we have 4 time zones to split up this large landmass. China, for all intents and purposes, is almost the exact same size and width of the United States, yet there's only 1 time zone in China. Okay, so again, 3 p.m. here on the west side of China is going to be completely different than 3 p.m. on the east coast of China. And again, why did they do that? Well, that's what the politicians and the people that are in charge and the people that run the country decided to do. Okay. The whole point of all this, what I'm trying to emphasize to you guys with this time zone stuff, is that it is related, absolutely 100% related to longitude, okay, from its scientific perspective. And then decisions would be based on that information, okay? International dateline, let me just reemphasize a couple things. Say, for example, you are on this side of the world and you fly in a plane going in this direction like this, okay? So from, this would be considered east. So you would be flying actually west to east like this, in an eastern direction, from west to east like this, okay? And if you cross the international dateline like this, let's say it's Tuesday here, and then you cross the international dateline like this, okay? Going in the eastern direction, what's gonna happen is Tuesday will become Monday, okay? Tuesday will become Monday. So it's like you go back in time. Now, if you were to go the other direction, let's say it's Tuesday in Los Angeles in this example. If it's Tuesday in Los Angeles and you actually fly westbound and you cross the international dateline and you land somewhere over here, what's going to happen is you will add a day. So it's like you've gone forward in time. There's many different ways people phrase this. But if I ask you about this and you respond, and I know that you understand going, you know, the difference going from an eastbound versus westbound, what ends up happening, that's what I want to see, okay?